whichever it is for you. Right now you're looking at a whiteboard. And these are the two ladder rails which we've been talking about. This rail right here is the neutral. And this rail over here is, and we're going to say, we're going to stay with 24 volts. And we'll say that this is the 24 volt rail. Okay. Now then, one of the other things that we've mentioned so far in our discussions is that we have a relay or a contactor coil which can be used to start anything, put it into motion, and what I have is a momentary push button. Okay, if I push this button, it will bridge the mechanical gap between these 2 points. We will apply 24 volts to this coil. Current will flow, and that will produce a magnetic field which will move the armature of whatever this device is, and with that we can start a motor, and we'll leave it at that. We'll say that will be used to start a motor. So what we will do is we will name this push button start, and we'll call this coil MOT for motor, and that goes along with the idea that we're going to use it to start a motor. Now the ladder logic, you see this looks like a ladder. I've got a ladder rail here, a ladder rung right here. The MOT coil is the output, and for this circuit we only have this push button, okay, for the input. So let's get some definitions down here real quick. What we want to define is an input device if it is not actuated, in Boolean logic we say that this is a state of 0, not actuated, meaning that no one has pushed that button. If it's actuated, then we say that the binary state is equal to a 1. So if I am not pressing this button, its binary state is a 0. If I am pushing that button, the binary state is a 1. Now then, MOT is the output, start is the input. So the Boolean equation, and it is an equation, is such as the output, MOT, will be actuated when start is actuated. So we just simply say that motor is equal to whatever the start button is. If the start button has not been actuated, the motor coil has not been turned on. So if start is a 0, MOT is a 0. Okay. If we do push this button and apply 24 volts to the coil, then in this case, start button is actuated, therefore the motor is actuated, or the MOT coil is actuated. If the binary start is equal to a 1, then the binary value or state of coil MOT is a 1. Okay? So, very simply looking at this just and keeping it simple, this will be a 1 whenever this is a 1. This will be a 0 whenever this is a 0. This will be actuated whenever this is actuated. This will not be actuated if this is not actuated. Okay? So, mathematically, we like to think of it in terms of 1 and 0. And I've got my cat on the keyboard. Let me put her down on the floor and see if I can get through this. And this is one of the most simple circuits you'll ever see. There you go, quite simple. The Boolean statement is right there. And remember, what we've been working with is we've been working with ladder logic, and we're using a hardware system here in which I've got 24 volts on one side, left rail, and the output is the remote control device, MOT in our case, which is connected to the neutral side. The two sides are joined together whenever I press this button, and if I do that, then I energize the coil, motor starter starts, and motor turns. Okay, so with this, we can write a truth table, and we will put our inputs on the left-hand side. So we'll call it. Let me change colors, please. So we'll have the state of start on the left-hand side and the state of MOT on the right-hand side. So start, which is a push button, can be either a 0 or a 1. And for our circuit, the motor is a 0 when start is equal to 0, and the motor is equal to a state of 1 when start is equal to a 1. That is our truth table. Okay, just for future use, or just for the fun of mentioning it right now, whatever start is, motor is also. So this would be called a truth table for a yes function. Okay, so meaning yes, the output is equal to whatever the input is.